This video will talk about the properties of solids. First off, just to go over in general, solids, in terms of shape and volume, they have a defined shape and a defined volume. They do not take the shape of their container. Their particle movement, the way we describe it, is that particles vibrate in place. They're not flowing, they don't move around, they're kind of locked in place with respect to the other molecules, and they vibrate. That gives them a fairly low kinetic energy, and in fact it's the lowest of all phases, and solids therefore exist at low temperatures, because remember, we say that the temperature is a function of the average kinetic energy of the material. Their particle distance, the particles or the atoms or molecules are relatively close to each other, and therefore in most cases solids have the highest density of all phases, although there is an exception. So I want you to think about what that exception would be. It's something that you encounter every day. The other thing that I want to talk about with solids is their molecular structure. The first type of molecular structure that solids can have is a crystalline structure. They are defined as a neat, repeatable arrangement of molecules. Crystalline solids on the molecular level are very orderly and geometric. The basic unit of the solids are called unit cells, and that's defined as the smallest arrangement of atoms that have the same symmetry as the whole crystal. And examples of crystalline solids include salt and volcanic rock that is slowly cooled. So if we want to think of a crystalline structure as something that is very orderly, for example, if I had students arranged boy, girl, and I gave you enough time as you walked into the room to get into that arrangement, then you could form a very, quote, crystalline type of structure. The other molecular structure that solids can have are amorphous structures, and these are pretty disorderly. They're very random. There's no repeating structure. And an example of amorphous solids are volcanic rocks that have rapidly cooled. And so an example like that would be if your goal was to try to get into boy girl arrangement, and you walked into the room at the beginning of class and I said, okay everyone, get into boy girl arrangement, go, stop. Then that would be something that is rapidly cooled, and you would not be able to get into that type of an arrangement. You wouldn't have enough time. And so if I have volcanic rock that is rapidly cooled, then it would be amorphous because it would not have time to get in that nice orderly structure.